So this presentation aims at introducing the technical specification of a new standard, an MPAI neural network watermarking. We currently release this technical specification as for consultation to the expert, both inside MPAI and outside the body, and we'll be very happy to have some feedback and to know whether or how can we improve this technical specification. So the document was distributed with the invitation, but if you would like to have it again, don't hesitate to ask our secretariat. Okay, some brief introduction about MPAI. So MPAI deals with moving picture, audio, and data in the broadest acceptation, coding with the use of artificial intelligence. It's an international, unaffiliated, and non-profit organization. It's the AI-based data coding standard. It's the main trend, but as you will in MPAI, but as you will see, we also deal with other type of processing and other type of operation related to AI structure, like it's specifically the case of NNW, neural network watermarking. One of the peculiarities of MPAI, its commitment to have very clear and transparent intellectual property rights licensing frameworks. And the approach, the technical approach, it's incremental. It is component-based. First of all, the AI application, it's subdivided into modules. What we call AI modules. These modules works together thanks to workflows, AI workflows defined on the top of the modules, and they are executed into a standard environment, AIF, like AI framework. Although sorry for that. Although the MPAI history, it's not that long, at least when I speak about long, it's at least with the common expectation of standard lifetime for the inception of the idea up to its release, we can say is that this history is successful. Because several standards are already released. This is the first one, the foundational standard related to the framework. Then there are 3 application standards based context-based audio enhancement, compression and understanding of financial data, and multimodal conversation. While at the ground and for ensuring the functioning of everything as a system, fifth project is released, governance of the MPAI ecosystem, and this is a system standard. Currently, the activities are very broad. So we are about to approve this neural network watermarking. So as I told you, it's open for discussion. We work on extending the previous 3 mentioned functional standard, and we are developing avatar representation and animation. There are also 6 exploratory activities related to AI and its usage in health, with connected autonomous vehicles, with server-based predictive multiplayer gaming, with end-to-end video coding, with enhanced video coding, and with XR values. As they are adopted so far. The standard are promoting under the IEEE framework, and you have on the under this slide their numbers. So the three of them were promoted in 2022, and their number as 33 families of 33,133.2. Let's come now to our work on a neural network that takes place here under the MPAI framework. And yeah, as always, when starting a presentation, there are general things to be told about neural network, and we ask ourselves, what can we still told as general things about neural networks? And we specifically choose some of detailed aspects related to the MN deployments. Their deployment fields, it's very, very broad, and they are continuously renewed. Frameworks are established, some solutions are promoted, are standard, are ready to be taught to students and to be taken aboard by engineers. But the renewing process is on its way. And specifically related to their usage, they are more and more at the heart of autonomous systems. Autonomous systems can be robots, can be vehicles, can be some decision-making systems. And not only on general purpose tasks, but more and more in critical domains. I speak there about medical decision. We can speak about autonomous vehicle with passengers. So yeah, we put on this slide unmanned vehicles there. I rather think about drones or things like this that are expensive and that are deployed for serving some tasks. But such vehicles may also have passengers, and this can change, this can result in not only in material, in money lost, but also in life loss. We consider that watermarking is useful for neural networks because, as already stated on the previous slide, there is the issue of the cost, of their cost. Buying a professional AI solution, according to some sources, ranges today from $6,000 up to $300,000 US. And renting a pre-built module also costs a lot. As an average price, we find statistics showing that we can speak about $40,000 US a year. And not only the cost, but also the usage brings this topic of watermarking and neural network to light, because an AI solution, and I speak here about the solution as an end-to-end solution, can use multiple alternative neural network to provide an inference, and identifying the ones that actually produce that inference, it's important. Neural network can be shared among multiple users in an organization or in different organizations, and keeping a track of this process, it's useful. Neural network can be also altered by their common life cycle, or malicious modified. We put there maliciously attacked. So identifying the modification, it's essential to avoid faulty functioning, mainly in critical tasks. So we consider that watermarking can provide a solution to this tracking of usage and to this authentication of the integrity. And watermarking, it's inherited from multimedia world. It's some 20 years, maybe 25-fold research field, and deals studies and provides a solution that allows some data, some metadata, we can call it a payload, to be inserted into an original content in a way that it's imperceptible for generally for the human visual system, for the one who watch the video, and that it's persistent in the sense that once inserted, it can no longer be removed without damaging the content. So the multimedia watermarking problem, it's stated as an information theory game between the quantity of information to be sent through an abstract channel represented by the content in itself, while observing two constraints: imperceptibility, that it's considered to be a power constraint at the enter of this channel, and robustness, that it's considered to be minimal constraint for the noise existing on the channel. And while the field is so broad, I would just insist on the fact that shifting from multimedia content to neural network as a field of protection, it's not straightforward. First of all, watermark insertion is no longer a static process, but a dynamic. Because the watermarking can be also inserted during the training. So we don't always have a content, a natural network that it's frozen and we came and inject something inside. But on the contrary, this information, it's iteratively inserted with each epoch of learning. So the object to be watermark change with each iteration. And on the other side, at the detection side, note that although always the mark is inserted in the neural network, it can be detected from the model itself or from the inference that module produced. So we completely leave here the conventional multimedia framework. And a second problem relates to the evaluating the watermark impact on the inference. And this process becomes now much more complex than for multimedia quality. Finally, multimedia quality was, of course, it's a very sophisticated research field in itself. But finally, we have a common ground that is, at least for the large majority of the application, users should be happy with the watermark content. Here, it's no longer the case, as the watermark embed in the model impacts the inference. So the evaluation of the inference, it's intrinsically dependent on the task the neural network achieves. So we have these particularities related to the insertion, to the detection, and to the evaluation of the quality. And in order to fix the ideas as in conventional, in standard development, we identify several use cases. Their narrative, it's very close to the applicative field, and I really invite you to read the detection, but to read the description, the detailed description, sorry for that. But in order to make the whole story short, these use cases can be structured on three directions. First of all, it's to identify a neural network. So the data you insert, the data that should withstand attacks, after they are retrieved, they convey information about the neural network in itself. I wouldn't like to give too particular example, but yeah, to make it simple, imagine that this watermark it's a kind of DOI for a neural network. The second class of use cases relates to identifying the actors of a neural network. So the data conveys information about some or all of the actors involved in the neural network life cycle. These actors are of various types. These actors can be the one who create the model. These actors can be the one who buy the models and want to further legally distribute it. Actors can be also the final users. So all this type of positioning and all this type of actors came with different constraints. But what is mainly important is to be able to identify them, so to associate some unique identifiers. And the third family, it relates to verifying the integrity of a neural network. So the neural network, the integrity of the neural network can be judged, can be assessed according to the data that was conveyed. We may have here a binary answer, yes, the network was modified, or not, the network was not modified, or we may have richer information identifying the layer or the neurons that was modified or the type of modification. So the discussion here can be very, very broad. So after this introduction to the problem, after presenting the three types of use cases, identifying the network, identifying the actor, and ascertain the integrity of the network, it's time to state what MPAI NNW technical specification, and we hope by the end of the month the MPAI NNW standard deals about. MPAI NNW specify methodologies to evaluate three aspects, key aspects of a neural network watermarking technology. First of all, the impact on the performance of a watermark neural network and or on its inference. So what is the impact in performance induced by the mark injection? The second topic relates to the ability of a neural network watermarking to detect or to decode a payload when the watermark neural network has been modified. So if the first one mainly relates to the transparency, the second one relates to the robustness concept. So we know, we expect that neural networks are modified during their life cycle, and we like to make sure that even in this situation, the mark can be recovered, or at least to evaluate the capacity, the property of a given method to withstand these attacks. And why this precision in detector and decoder? As I just precise, this watermarking detection can be binary, so only one decision, yes, a mark has been inserted or not, the mark was not inserted, can be obtained, and that we speak about watermark detector, or can be a multiple bit payload, and then we speak about decoder. And so after the transparency and after the robustness, we investigate the computational cost. What is required as computation in order to insert, to detect, or to decode a watermark. As you may see, we do not make here, and this standard do not cover aspects related to the data payload. As we state in the first sentence, we consider that the data payload is set. It's for a fixed data payload. We discuss this property. Of course, if data payload changes, then this evaluation will change also, and this aspect can be brought to the discussion. But in order to reduce the complexity of the evaluation, we made this decision. Yeah, I never know if a picture is better than 1,000 words or not, because in compression there is always the discussion on what you need to compress 1,000 words or one image. But we also draw this this image as a recap of our standard specification. So on one side we have the one who provide the watermark technology, and that makes available for tester the injector, so the technology for injecting the watermark, as well as the detector or the decoder according to the technology. We also have the MPAI tester. So the MPAI tester is the entity in charge with the evaluation. The first step relates to the inserter and to the transparency property, and follows evaluate the modification of the performance induced by the watermarking process and the processing cost of the insertion. The second part relates to the detector or to the decoder, so to the binary or to multi-bit detection. And it's the standard specify performance criteria for the detector decoder, as well as the processing cost of the detection and decoding. So too small precision. I always spoke about detector and I say it provides a binary decision, yes, not. In some multimedia study, early multimedia study, some 20-something years ago, this was referred to as a 0-bit watermarking. Actually, it's 1-bit watermarking. The second discussion, I told you that MPAI tester, and I think I used the word, is the entity. This MPAI tester, we at the level of discussion, and for the standard stays abstract. Of course, it will be after that work inside MPAI to see how this tester behaves, whether it's really a human or a process, or mixed human and automatic process. So what standards specify imperceptibility evaluation? The standard specify the need for defining a pair of training and testing data sets with the size at least 10 times larger than the number of trainable parameters. So this is the general rule of thumb in a neural network training. The watermark, it's applied to a set of one unwatermarked neural network trained on the task. So this watermark can be done once the neural network are trained, or during the training of the neural network, according to the watermarking solution itself. The unwatermark and watermark NN are fed to the test data, and the quality of the produced inference, it's evaluated. So here, this evaluation of quality should be considered in its broadest acceptation, and relates to the task. First of all, can be reference quality evaluation or no reference quality evaluation. Just imagine a classification task. We can simply evaluate the performance of the watermark neural network and say, as far as the classification accuracy is larger than 95%, we are happy. Or we can make some reference evaluation telling that initially was 96.3 and after that it's 95.7 and so on. Task dependent, of course, we cannot evaluate the quality of watermarking technology independent with respect to the task. The task and our use cases relates, of course, to classification, to prediction, but we have use case related to speech synthesis, and then, yeah, the quality should be evaluated according to the common usage in speech evaluation. At the same, seeing the quality of watermarking a neural network in an end-to-end video coding should observe the criteria of the inference of the specific inference that it's used for. Let's go now to the second item, robustness evaluation. And here, again, we define a pair of training and testing data sets. Here again, observing to these constraints in size being at least 10 times larger than the number of trainable parameters. The watermark is applied to a set on one watermark neural network trained on the task. And one attack, it's select and apply. The standard provides details about the attacks to be considered during the evaluation, as well as about their parameters. So, for instance, the common Gaussian noise addition, we specify how the variance of the noise should be chosen with respect to the neural network, what type of pruning, if it's in L1 norms, and what parameter to be used as threshold for L1 norm or for the random planning, how quantization can be applied on neural networks, because this is a discussion in itself, fine-tuning, knowledge distribution, or distillation, sorry, or watermark overwriting. So after applying this attack, the robustness of the detector or decoder should be evaluated, and here it's about identifying the modification in the detector or decoder decision. So if the mark is binary, it can be a bit error rate, it can be multi-symbol error rate if it's multi-symbol watermark, can be also, if for the binary cases, can be probability of false alarm, probability of misdetection, F1 score, so everything that relates to the specific detector or decoder. Thirdly, the computational cost. And in order to follow a pragmatic approach and to have a standards that can be implemented, we decided to evaluate these parameters through the memory footprint required for the watermark insertion detection and the total duration of the process on some specific platforms. So it's not here about evaluating the complexity of the operation in the sense of number of addition and multiplication, because this is too much task and training dependent in neural network. It's about evaluating time. So the workflow, it's define first the elements to be evaluated for characterizing the injection process, but also for the detection King's cross, the memory footprint, the time to execute the operation required by one epoch, normalized according to the number of batches processed in one epoch. In case injection is done concurrently with network training, the number of epoch required to insert the watermark, and the time for the watermark neural network to compute the inference. As I said, for the detection decoding, it's only the memory footprint and the total duration of the process. So here we are at the end of this presentation. The next step, please send your feedback to the Secretariat until 23 of this month, so 23 of January 2023 at 23:59 UTC. And we expect the standard taking aboard your comments and your feedback to be approved later on this month during the MPAI General Assembly to be held on 25 of January 2023. So you may find more information about neural network watermarking at nnw.mpai.community. So nnw.mpai.community. Thank you.